Welcome to doassignment-ca. Here's the problem. Solve each compound inequality and graph the solution on a number line. Part A. -4 is less than 2x plus 6, which is less than or equal to 14. Part B. 3 is less than or equal to 5 minus n, which is less than 9. For Part A, also describe the solution in words, write it in interval notation, and create a real-world scenario modeled by the inequality. Now, let us work through the solution step by step. A compound inequality chains two inequalities together around a single expression. The solution must satisfy both parts at the same time. We isolate the variable by applying the same operation to all three parts. The one rule to watch: if we ever multiply or divide everything by a negative number, both inequality symbols must flip direction. Here is the number line for Part A. The shaded region stretches from -5 to 4. An open circle sits at -5, showing that value is excluded. A filled circle sits at 4, showing that value is included. The solution in interval notation is open parentheses -5, 4, close bracket. Here is the number line for Part B. The shaded region runs from -4 to 2. There is an open circle at -4, meaning that value is not included. There is a filled circle at 2, meaning that value is included. The solution in interval notation is open parentheses -4, 2, close bracket. For Part A, we start with -4 less than 2x plus 6, which is less than or equal to 14. To begin isolating x, we subtract 6 from all three parts. That gives us -10 less than 2x less than or equal to 8. Now we divide every part by 2. Since 2 is positive, neither inequality symbol changes. We get -5 less than x, less than or equal to 4. The left side is a strict inequality, meaning x cannot equal -5, while the right side allows x to equal 4. In plain words, x is greater than -5 and less than or equal to 4. In interval notation, we write open parentheses -5, 4, close bracket. The parentheses on the left shows -5 is excluded. The bracket on the right shows 4 is included. For a real-world scenario, imagine a variable fee of $2x plus a base charge of $6 gives a total of 2x plus 6. A discount applies only when that total is more than -4 and at most 14, the same compound inequality, with solution x in the interval open parentheses -5, 4, close bracket. For Part B, we start with 3 less than or equal to 5 minus n less than 9. We subtract 5 from all three parts to begin isolating n. That gives us -2 less than or equal to -n less than 4. We now need to eliminate the negative sign in front of n. We multiply every part by -1. We multiply by -1. This is the critical moment. Because we multiplied by a negative number, both inequality symbols must flip. Less than or equal becomes greater than or equal, and strict less than becomes strict greater than. We get 2 greater than or equal to n greater than -4. Rewriting that left to right in the standard way, the solution is -4 less than n less than or equal to 2. The solution for Part B is n greater than -4 and less than or equal to 2, written as open parentheses -4, 2, close bracket. To verify, we plug in n equals 0, which is inside the solution. 3 is less than or equal to 5, which is less than 9, true. Plugging in n equals 3, which is outside the solution, 3 less than or equal to 2, is false, confirming our boundary is correct. To summarize, Part A gives x in the interval from -5 to 4, not including -5, including 4. Part B gives n in the interval from -4 to 2, not including -4, including 2. The two key techniques are: apply every arithmetic operation to all three parts simultaneously, and always flip both inequality symbols whenever you multiply or divide by a negative number. Use open circles and parentheses for strict inequalities, and closed circles and brackets when the endpoint is included. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.